Hi folks, we're going to take a look at question 4C on page 109. So they give us the equations of two lines in 3D, and they want to know whether they intersect, and if they do, find the intersection, and if not, are they parallel or skew lines. So best way to begin any one of these problems is to look at the two direction vectors. Okay, and we notice here that these direction vectors are definitely not parallel. They definitely aren't scalar multiples of each other. So right off the bat, we can make the we can interpret that these lines are not parallel, otherwise their direction vectors would be parallel, and they're not coincident. Okay, meaning they don't represent the same line, because again, the direction vectors would have to be parallel. So let's move on to showing whether they have an intersection or whether they're skew lines. Okay, so the way we do that is try to find an intersection. So remember, if they have a point of intersection, there's a point XYZ that lies on both of these lines. So if it lies on the first line, it means that the x components would have to be equal. Okay, so x1 would have to be equal to x2. And let's look at what x1 is written as in equation 1. So x would be 2 plus 1 times t. So for some t value, 2 plus t would have to be equal to the x component on the second line. So negative 1 plus negative 2 times u. So negative 1 minus 2u. Okay. Now, similarly, the y components would have to be the same. Oops, alright, y2. So here, we look here for that same t value, negative 1 plus 2t. So negative 1 plus 2t would have to be equal to the y component here. So 1 plus 1 times u. So 1 plus u. Okay, and the z components would have to be the same. Okay, so look at the z components, 0 plus negative 3t. So negative 3t would have to be equal to 2 plus 1u. So 2 plus u. Okay, and what we have here are three equations, but with only two unknowns. Now we can only solve two equations and two unknowns. So what we'll do is we'll take two at a time, okay, and solve for t and u, and then find whether that same t and u will satisfy the third component that we didn't use. So when you're solving a system of equations, okay, I would suggest normally doing that by elimination. And I notice here that if I take a quick scan, I've got a u here and a u there. Okay, so these are the two equations that I'm going to use because I think they're probably easy to eliminate with. So I'm going to call equation 1 here. I'll take this equation and I'll bring everything to the side of u. So let's see what we have here. We have u. Okay, then this 2t will become minus 2t. Okay, and then here this negative 1 comes to the other side, becomes plus 1. So plus 2 is equal to 0. And then here, the second equation, I'll take this one here. So u, okay, bring the 3t to the other side, so plus 3t. And then here, we're just left with the plus 2 equals 0. And now I'm going to subtract these two equations in order to eliminate the u variable. So u minus u is 0, negative 2 minus 3t, so negative 5t, and then 2 minus 2 is 0. Oh, that works out nicely, so equals 0. So t, if I divide both sides by negative 5, still gives me 0. Okay, so I know that t is going to have to be equal to 0 to make these two equations solved. And so now I'll use one of them to determine the u value. So this one looks pretty good here, so I'll take equation 1. So u minus 2 times 0, since I know t is 0 plus 2 equals 0. And since u is going to have to be equal to, take the 2 to the other side, negative 2. Okay, so in order to solve the system of equations, t had to be equal to 0, and u had to be equal to negative 2. Okay, so let's see whether this value of t and this value of u will make the x coordinates equal. Okay, so let's check that here. We'll take x1 is equal to 2 plus t. So here 2 plus 0 equals 2. Okay, and let's find out if I get the same x value when I plug in u equals negative 2. Okay, so here x2 is equal to negative 1 minus 2u. So that's equal to negative 1 minus 2 times negative 2. So we have negative 1 plus 4 is 3, and we see that they are not the same. Okay, meaning that the t and u values that made the y values and z values equal do not make the x values equal. That means there is no point of intersection, so the lines are skewed. Okay, and there we go. There's the end of the problem.